Welcome to the DigiFabster Spring Product Update webinar. My name is Abby Sandbach, and I'm the Marketing Manager here at DigiFabster. Presenting the webinar today is Michael Stoy. Before I turn it all over to Michael, I want to point out the questions panel on the right-hand side of your screen. At any time, if you have a question, please feel free to type it in there, and we'll make sure we have plenty of time to answer questions at the end of the webinar. With that being said, Michael, take it away.
Perfect. Thank you so much, Abby. So now everyone should be able to see my screen. So what we want to discuss today is the spring update, some of the big updates that have happened to DigiFabster in the past months. With this, it's a great way to review and talk about some of the new updates. Then if you have questions about any of the new updates or about how we can set up any of these new updates to help you, that's what this webinar is here for. So again, as Abby mentioned, if you do have any questions, please ask them in the question field. And at the end of the webinar today, we'll be going through all of those. The biggest update that we've had so far in this spring update has been mostly related to our CNC side. So what we'll do to start off is let's go through setting up a new CNC machine, and we can talk about some of the changes. So we can start off by going to Machines and Materials, and then we can go to our CNC tab and create a new machine. The first update that we've had since the spring update is we now have the ability to have in different machines and different technologies for 3-axis milling. So with our 3-axis milling, what we can do is we can price parts differently if they can be milled on a 3-axis machine with no additional reclamping. So this is a great way if we want to make the very simple parts even more competitive. It's another great way to allow customers to choose that. In this case, let's just choose a 3-axis milling machine. We can always create our own custom machine, and we'll be adding in a list of common 3-axis mills into this example as well. We can again then choose in a travel distance, and we even have a minimum part size, which we can just set to 0 for this example. I'm not going to do a full pricing algorithm, but we'll quickly skip ahead to the actual feature recognition part. And feature recognition is something else that has been greatly improved upon since our winter update. So with feature recognition, we'll analyze for holes, and we can even allow customers to choose to pay additional options for different hole types. So for example, we can have a threaded hole. Since we are working in a cuboid system, it makes more sense to use a cuboid feature type, but we can also work with axial and radial for our turning machines. And with this, we can have additional costs for an axial hole versus a radial hole. We have the ability to have a price per feature and then a startup as that setup cost. So we can say in this case, maybe I have a $5 setup and then $2 per each feature. And then we just need to activate it. And just like that, we set up threaded holes for our parts. The benefit of using our newer and updated feature recognition is we can have the ability to have other types of holes as well. So if we didn't want them to be threaded and we just wanted them to be a single bore hole, we can create those as cuboids. We can set up a price of maybe $1 and a $2 startup cost. So with this, customers will be able to choose between the different types of holes that they need for their parts, and they'll even also be able to change the quantity. And we'll show that off in a little bit once we actually get to the e-commerce widget. Well, nothing has changed with our lead times, but we can save our machine. We can save our machine, and now we can go to our material. So let's choose just aluminum in this case. And again, we have changed some other big things inside of our materials. So we'll start off with the largest one, which is our different types of startup costs. So traditionally, we've had startup costs where what would happen is the startup cost would be applied as almost like a line item. And we can have this be charged in multiple different metrics, including per model, per order, per unique material, or per unique execution. So if we had a high tolerance and a low tolerance option, we could trigger it twice. The new add in the spring update is this programming cost. With the programming cost, it will automatically be triggered per unique model, and this cost will be baked into the part price overall. So for example, if we had a $100 programming cost, and if we printed and we machined one model, it would be $100 plus the cost of manufacturing. If we were to machine 2 different models, this programming cost would automatically be split among the models, and it would be $50 per each part. So it's a great way to bake in these additional costs so customers won't be able to see fully how we price, but we can still have these accurate pricing algorithms in the back end. The other big difference that we've added is the different types of materials that we can use inside of DigiFabster. So we can allow now for bar stocks, round stocks, and also price per kilogram. And with this, allows shops just to have different materials and allow customers to choose which one best fits their needs. If we are machining a part that round stocks might make more sense, what we can do is we can change our length and diameter, and we can even charge per different length of material. We can do something similar with our bar stocks, where instead we just have an XYZ coordinate for each piece. The other option, if shops prefer, is we can just charge off the density. So what we can do is we can set the density to 1 if we want to charge our volume, or we could use the density of whatever the actual material is and then just charge per kilogram of weight. Let's go and create a post-production type, and this is something else that I wanted to talk about. So when we go to our post-production, again, as always, we can choose to charge up multiple different metrics, including the model surface area, the model volume, the volume of the bounding box, or per part fee. The new addition that we have is this additional expectation of production times. This is a way to give customers more accurate estimates of when their parts will be ready. So for this case, let's say polishing takes an additional 2 days to polish the parts, and it's a $20 part fee. This is a great way, and this will show on the widget, of a way to give customers more expectations of how long their part will actually take. And if we scroll all the way up on top, we also can say an additional production time for each part. Most shops can leave this as 0, but if we wanted to say large parts may take up to 3 days to machine, we can set that up as well. When we're happy with this, we can save our material. And just like that, we've set up one of our new machines. So now what we can do is we can go over to the widget, and let's go and walk through the widget. So what we can do is we have 2 different parts that we'll quickly show off, and I believe we showed these off in a webinar before. But the 2 different parts are designed to be needed to be machined on 2 different machines. So for this, would need to be machined on multi-axis milling, because although a lot of the contours can be machined with a 3-axis mill without reclamping, we would need to reclamp for these 3 additional holes. So this would be a multi-axis part. If we were, as a customer, to select a 3-axis milling, we'll automatically notify them that this model is not suitable for the technology. Let's add this part to our cart, and then select the other one. And inside this other part, identical part, except for we don't have the holes. Because of this, we can head over to our 3-axis milling, and again, we can have a more competitive price because this is a much more simpler part to machine. And let's add that part to our cart as well. When we go to our 3-axis, we can choose aluminum. We can choose the different tolerance options, so low or high. This is the different types of fulls and feature recognitions. So if we go back to this part, we have 1 single hole in it. If there were multiple holes in it, we could also allow shops to, or the end user to maybe only have 1 of them threaded. We can also just choose just a regular hole, and this will change the price in real time. Next is priority, and then we can also choose additional polishing, or anodizing in this case of parts. What we can also do is proceed to the cart. Inside the cart, we're now able to see all the different parts, and we can see the different lead times for all the different parts. The big update with the spring update is we now have on the last page, we'll have an estimate of when the customer will be able to actually receive their parts. So as we can see right here, our estimated manufacturing time for these parts is 12 days. It's a great way to, again, give customers more information and more feedback than as opposed to just giving them an estimated lead time or any other information. So this allows shops to provide customers with more accurate manufacturing times. And with this, customers we found have been it's more convenient for them to understand when their parts will come in, along with they have that much more realistic time. So they don't expect their parts to maybe be sent overnight if they chose a 1-day lead time. Then what we can do is confirm the order. And then we can go into the back end of DigiFabster and we can talk about some of the updates that have happened in there since the spring update. The first big thing that's happened in the spring update is we've given shops more ability to modify customer information. If we wanted to, Let's say we're using an internal quotation tool and I accidentally sent this to myself instead of a customer. We can just create a customer's name and a last name for them. And just like that, we can update. So we have a new customer, we have a new phone number, we can send out a new email address. So it's another way for shops to be able to manage and update quotes and invoices if customers maybe need it sent to someone else, or if shops just need to modify it themselves. It's a great tool again to streamline the process, and if there are any difficulties, we can go in and make it easier for shops instead of needing to contact us to update an order. The other big thing, if we go back to the Orders tab, is we've added the ability to more easily bulk download models. So as always, we can quickly bulk download and download the packing list and invoices. What we've changed is we now allow shops to also download the original models along with the repaired models. This is most beneficial for machine shops. So if we do want the initial step file or IGES file that a customer has uploaded, we can download the original ones as opposed to the repaired ones. When it comes to 3D printing, again, shops can have the ability to choose if they want the original models that the customers upload themselves or download it in a repaired model. Some other changes that I want to talk about quickly that we can't show off right now is we do have the ability to trigger manual review. So what happens is if a customer uploads a part, and with this part, if they don't upload a PDF with the part, we can automatically hold these parts as well. So this way we give shops more, it's another way to use our manual review system. With this, we can hold those orders for review, so a human can review them, make sure everything's machinable, and then, or if there are any ambiguity on how the parts be machined, and when they're happy with that, then the customer can pay for the parts. Some other changes that have happened in the Spring update. One of the big ones is we've improved rendering for DXF models. So this again just gives shops at a glance, they're able to see what the DXF models look like, and then they can view at site and see exactly what they look like. We've also been working on adding in additional integrations and allowing DigiFabster to be used with multiple different softwares. One of the biggest integrations that we've been working with is a Xero integration. With this, customers have been able to log and send out billing information through Xero. So if you're interested in seeing a Xero integration set up or see how that workflow might work for you, please reach out to us after this call. The other big update that we've had is our vendors program. And similar to Xero, our vendors program is a add-on feature. What this allows though is with this, we can go in and we can select parts for ourselves to be manufactured, or what we can do is we can always send them out to a vendor. With this, we can send out the part and the material and specifications to a vendor, and we can allow the vendor to machine it and then send it out directly to the shop itself or to the end user. So depending on how you want that set up, we can also configure that as well. It's a great tool if the shop is work with multiple different vendors. If we want vendors to bid on parts, and then if we want to assign parts to each vendor, it's a great way to help manage that all inside of the back end of DigiFabster. With that, those covered everything that we wanted to show off today in the Spring update. If anyone has any questions about any feature in depth or any questions about DigiFabster at all, please feel free to ask them now. I'll give you a couple of minutes to start typing up responses. I realized I accidentally hit mute. So something I wanted to show off quickly again was the feature recognition. So with the feature recognition, what happens is feature recognition will show all the different holes of a model, and all of these holes are broken up depending on the hole diameter. So for example, if we wanted some of these holes threaded and some of these just non, we can support that as well. So we can instead select that 0 of these parts are to be threaded, 0 of these are to be threaded, and maybe only 1 of these are to be threaded. So we give shops and customers better ways to interact and designate what they want with their part. And then on top of that, when we have the PDF and engineering drawings of the parts, shops won't have that ambiguity of what holes need to be threaded or what else. So it's a combination of allowing end users to submit what they need, along with shops themselves would be able to analyze and come back if we do need to maybe modify some holes and machine them in a certain other way. Another question that I see come in is that we do have some questions about when would we use a 2D cutting versus a Okay, so we have a question come in asking about specific material removal rates and how we can handle between roughing and finishing speeds. So with this, every single material has their own set rates. So for example, we set up our machinability, which is our theoretical rate. And then when we come to every single material itself, it has a machinability rate. So this is how we can normalize different materials. So again, we can machine stainless steel much slower than if we were to machine aluminum. So that's how we can handle different materials. And on top of that, we have theoretical numbers from looking at majority of our shops. But if a shop is very proficient at one material, we can overquote or underquote it compared to the other materials. So shops do have the ability to change the different machinability for each material to meet their real world numbers. The next question was about finishing speeds and feeds. So we do analyze how complex the parts are to machine, but if we are to do lots of finishing passes and finishing speeds, we do have the ability to analyze and add in additional charges for those. So again, depends on how each shop is operated. But if shops do spend lots of time finishing their parts and between roughing and having high quality and very high tolerance parts, we can match that in our system to account for those as well. The other question that I saw come in comes about shipping costs. So with shipping costs, I can quickly show off how they're set up. So with shipping costs, what happens is if we go all the way down here, we can choose different shipping companies. We also have the ability to have flat fees. All the prices from shipping, we work with a third party, which is able to analyze the APIs of multiple different shipping providers. And that's how we're able to get the prices for each courier. The other option that we can always do is have a flat fee. So let's say we wanted to have a local shipping option where we would drive the part out to the customer as long as they're within the city or within the mile. We can always create our own custom shipping option. And with this, we can have additional notes to the users. We can say that this is a city type pickup, and we can say this is $20. So we do have the ability to automate shipping. And with this, we can have our own shipping options that we created, or we can choose from one of the different providers, including Canadian Post, USPS, FedEx, UPS, and DHL. So again, it depends on how you want to set it up. And if you do want to work where we just have flat fees for customers, we can support that. Or we can get the live prices through the shipping company's APIs. And then also with that, if you do have negotiated rates with any of these shipping companies, we can also support that. So that's a great way if we have prorated rates, we can discount and send those discounts along to the customer. So it's a great way to enable customers to get the best price possible. Are there any other questions related to shipping or even machining in general that we can help with? I know this webinar was a lot more focused on our CNC side as opposed to our 3D printing, but even if you have questions about 3D printing, we can quickly answer them right now. I'm not seeing any follow-up questions, so I'll quickly talk about, we just had another question come in asking if we can configure machines and materials from existing orders. So when a customer goes through the order process, they do have, by default, they have already picked their material and the machine that they're using for their part. So in this case, we chose this aluminum, and we currently don't display the machine right here, but we have this all set up. If we were to want to modify and say maybe want to change this to be stainless steel or some other machining metal, we do have the ability to override this, but that's something that a shop would need to come to DigiFabster to update. And the reason being is for that is we've had customers in the past who've accidentally modified an order, and when we update the material, it'll update the price. And this way, we just want to guarantee that we don't accidentally modify an order where a customer is partially paid or has fully paid already. So it is possible to reconfigure which machine and which material for each part, and we'll also regenerate the price. The other option that shops can do is they can go to the part itself, then they can go to the price breakdown, and inside of here they can choose whichever different material, and maybe we can see that printing this part is much cheaper. So this is another way where shops can actually test with different machines to see if does it make more sense to machine this, to 3D print this, or to use another technology to support this. So this tool, again, it's a great way to help figure out the true cost of each part. We can also see how many hours it will take, how many kilograms of material, along with other settings that are adding to the charge. And then if a customer does want to, if we reach out and say it makes more sense to machine this part on this machine instead, we can always go to the repeat order. So what will happen is this will automatically bring up the parts with their material options already enabled and from the order. But if we wanted to, we can then manually go in and change this over to stainless steel. So we do have the ability to, with a quick button, send out a counter quote to the customer. And with this, we can change the material or any other specifications if we feel it'd be best practice and the customer would get the most use out of maybe a different material. And then when I know a lot of shops don't want to have to manually teach customers how to use the tool. So on top of that, we do have built-in ways to help direct customers to the right material and or the right technology. So right away, when we go to our machines and materials, we do have the ability to have a material guide. This material guide will show customers what is the right right material and right technology for their part. So again, trying to automate and direct customers by themselves to get the correct material. If we want to do something else, what we can always do is change the names and descriptions of this. So it's another great way where we can direct customers to which type of technology is best for their parts. Some of the shops who have been leveraging the tool the most, and we discussed this a little bit in our last webinar, is we do have the ability to override the names of these. So if we wanted to maybe change the description to something similar to a rating system where we can rate the price, the material strength, and the quality of the part. It's another great way to allow shops to fully define what the define those customers' expectations, so they understand maybe I should choose this technology for a more robust part, or maybe I should choose this for a more cosmetic part where I care more about the detail and it won't be an actual mechanical part. Are there any other questions that we can help with, or we'll end the webinar a little bit early today? So I'll just give another minute or so, but thank you everyone for coming out. And then unless anyone has any more questions, I'll still be here for another couple minutes, but thank you everyone for coming out today. I look forward to speaking with you soon. I'm not seeing any more questions, so have a good day, everyone.